Okay, let's unpack this. What does calculus, specifically that part about finding peaks on a graph differentiation, what does that actually have to do with the food that ends up on your plate?
Yeah, it seems like a jump, doesn't it?
It does. And if you're maybe wrestling with derivatives and integrals in a math class right now, you might be thinking, is this just theory,
Mm.
abstract stuff?
It's a totally fair question. But the math you're learning, it's definitely not just stuck in the classroom. It gives us these, well, really powerful tools for solving some very real, very critical problems in places you might not expect.
Right. So our deep dive today is into source material that looks at exactly this. Differentiation, optimizing crop yield. We're going to explore how these mathematical ideas you're studying are actually used.
Used by agricultural experts,
Great.
yeah, to figure out the absolute best time to harvest crops, to get the most yield possible.
Okay, so think about the basic problem for a farmer. A crop grows, its yield changes over time, right? It's not static.
Exactly. Harvest too early? Well, the crop isn't fully developed. You're leaving food, basically, potential yield, still in the field.
And if you wait too long,
Then you risk losing yield, or maybe the quality drops. Pests could get it, disease, or it just gets overripe, spoils. There's
mhm,
this window, a specific point in time where the yield is, theoretically anyway, at its absolute maximum.
and that's where the math comes in. Our source material digs into how you can model this. It shows you can often represent that crop yield as a function, a mathematical function of time.
hmm As time goes on, the yield changes. So you get this curve if you plot yield against time.
So the farmer's challenge, finding the best harvest time, turns into a math problem. Find the highest point on that curve.
And this is exactly where differentiation is, well, incredibly useful. It ties straight into the concepts you're probably working with, finding the maximum value of a function that involves finding where its rate of change is zero, just for a moment.
Right, the slope is flat at the very top of the peak.
Precisely. So for our yield function, that rate of change is just how fast the yield is going up or down at any given time. And mathematically, that rate of change, that's the derivative.
Okay, so the source material talks about studies where researchers, they take this yield function, calculate its derivative,
Mm-hmm.
and then they solve for the time when that derivative equals zero.
Yeah, that's the key step.
Yeah.
That point where the derivative is zero. That's what you call a critical point in calculus class. It signals where the yield curve flattens out. Could be a peak, could be a valley,
Or just a level spot.
or just a level spot, exactly. So they have to check it, maybe look at the derivative just before and after, or use that second derivative test you might be learning about.
To make sure it really is the maximum, the peak yield.
That's it. And what's really fascinating, I think, is seeing this abstract math procedure translate directly into a real-world decision.
Yeah, find the peak of the curve and applying it to get the most food from this field.
And the sources show it's not just theory. These models get built using real data for specific crops, different growing conditions, all that.
So it becomes practical.
Very practical. Being able to pinpoint that optimal harvest window using calculus means farmers can lean more on data, not just, estimation or how it's always been done.
And that precision directly boosts efficiency, right? Getting the absolute most from the land you're already farming, that has to be crucial.
Oh, absolutely crucial, especially when you think bigger picture.
So what here is pretty big then. The calculus you're learning isn't just homework. It's a tool with really profound real-world applications.
Definitely. Applying differentiation to optimize harvest time, it's not just about one farm being slightly more efficient.
No, when you scale that up across the whole agricultural sector.
Right. It contributes, and significantly, to increasing overall food production, often without needing more land. It's a direct line from your math class to, well, global food security.
Math helping feed the world, one optimized harvest at a time. It's pretty amazing.
It really is. It just highlights how the techniques you're mastering, they have these tangible impacts on, fundamental human needs, big industries.
Okay, so thinking about this, we've talked about watching growth over time and using differentiation to pinpoint that peak moment for harvest.
hmm
But what about the other side of the calculus coin? Integration.
Interesting question.
How might integration fit into understanding, say, agricultural processes?
hmm
Or maybe managing resources over a whole growing season? Something to think about, as you see how these different calculus pieces connect to the wider world.